Picture this. You're falling towards something so powerful that not even light can escape it. Welcome to the most terrifying objects in our universe. Black holes. These cosmic monsters shouldn't even exist. They break every rule we think we understand about reality. So how do they form? And what would actually happen if you got too close? Let's start with stellar death. Imagine a star many times bigger than our sun. It's basically a giant ball of hydrogen, constantly fighting a war between two forces. Nuclear fusion in the core creates massive outward pressure. Gravity tries to crush everything inward. For millions of years, it's a perfect stalemate. But here's where things get wild. These massive stars keep fusing heavier and heavier elements. Carbon, oxygen, silicon, until they hit iron. And iron is a fusion killer. It absorbs energy instead of releasing it. So iron builds up in the core like a cosmic time bomb. When there's enough iron, gravity wins the war instantly. The core collapses in less than a second. We're talking about something moving at 75,000 kilometers per second. That's a quarter the speed of light. The result? Either a neutron star or something far more extreme, a black hole. Now here's what's really mind-bending. When you look at a black hole, you're not seeing the actual hole. You're seeing the event horizon. Think of it as a cosmic point of no return. Cross this line, and you'd need to travel faster than light to escape, which is impossible. But what's beyond that darkness? Scientists call it a singularity. We honestly have no clue what this thing actually is. Maybe it's a point where all the mass gets crushed into literally nothing. Maybe it's something completely different. Right now, it's like our physics just throws up its hands and says error, does not compute. Here's a fun fact though. Black holes aren't cosmic vacuum cleaners. If our sun suddenly became a black hole tomorrow, Earth would keep orbiting normally. We'd just freeze to death because, no more sunlight. But let's say you decided to take a trip into one. This is where reality gets seriously weird. Time starts playing tricks on you. From Earth, people would watch you slow down as you approach the event horizon. You'd appear to freeze, turn red, and fade away. But from your perspective, you'd watch the entire future of the universe flash by in fast forward. You'd literally be watching time itself. Then what? Well, we think there are two possibilities. Both are terrible. Option 1. You get spaghettified. The black hole's gravity is so intense that your feet experience way more pull than your head. You get stretched like taffy until you're basically a stream of hot atoms. Option 2. You hit something called a firewall right at the event horizon and get vaporized instantly. Your survival time depends on the black hole's size. Small ones will kill you before you even reach the event horizon. Supermassive ones, you might have a few minutes to contemplate your life choices. And speaking of supermassive black holes, these things are absolutely bonkers. The biggest one we know about is 40 billion times heavier than our sun. Its diameter, 237 billion kilometers. That's 47 times the distance from the sun to Pluto. But here's the strangest part of all. These seemingly eternal monsters will eventually die. Thanks to something called Hawking radiation, black holes actually leak energy. Empty space isn't really empty. It's constantly creating pairs of particles that instantly destroy each other. But near a black hole, one particle gets sucked in while the other escapes. The black hole loses a tiny bit of energy each time. This process is incredibly slow at first, but as the black hole shrinks, it speeds up. In its final second, it explodes with the power of billions of nuclear bombs. How long does this take? The biggest black holes might take a Google years to evaporate. That's a 1 followed by 100 zeros. The universe will be cold, dark, and dead long before then. And somewhere out there, right now, a star is dying. Another black hole is being born. The universe doesn't care. It never does.